numpy we say on. Okay, this is a Python library used for working with the arrays. Okay, and it has also the functions for working in the domains for algebra, for Fourier transform, for matrices and all. Okay, even you can find some basic mathematical calculations, like you can perform some trigonometric operations too. I remember on the last day we did the So the last day we did the simpy, right? And there we saw how to represent all these things on a mathematical scales and how to represent any integral differentiation in some mathematical forms. All right. Today we'll be seeing how to calculate on those things. If we just can write up those things, how we can just calculate. So this NumPy was created in 2005. Okay, and it has came in very good existence with the scientific calculations, although with the SciPy and all. All right. So who uses this NumPy? So like those who have main goal to work on lists rather than on arrays, or those who are working in the data science sectors, or those who are working with real-time data, they use these things. Okay, so we'll just quickly start up all this. Now, for importing it, it's very simple. You'll just have to write import numpy as np and start importing. Now let's just see that what is the version. So let's see the numpy version. So we'll format it as this will be the format, and it is np dot underscore underscore, sorry, this is underscore underscore the version. Very simple, we are using 1.18.1. okay, now once you have imported up the things, as I said that we will be using it with the arrays, so it's very easy. Let's just say that you are building an array arr, and we have imported it as np, so we'll be writing up np in place of numpy, and that is an array. So array can be of multi dimensions, so we'll be discussing about the dimensions. So let's say if I'm writing 1 2 3 4 5 6 7, right, and so on the numbers if I'm writing up there. So this is an array. If we just see the type of this arr, we find it to be a numpy.nd array. Now what is the dimensions, right? What is the dimension of this array? So for checking the dimensions, we can go up with ndim, and we can find it to be one dimension, right? And also you can find the dimensions with the brackets, right? If it is one bracket in the starting, they can say that this is a one dimension figure, all right, or one dimension array. So that is how we can just look over the dimensions analysis. Okay, now then you have again. So let's say again we are making up an array, and we are saying it to be 1 2 3 4 5 6 7 8 9 10. So what is the number of dimensions for now? That is 2. And if we just print our array, so you can see it to be 2 dimensions. So starting 2 brackets, ending with 2 brackets, that is a 2 dimension figure. And you have all these things, right? Okay, so this is like the dimensions you can say on the numpy you get about the dimensions. Now what is then comes like what is the shape, right? What is the shape there? So what is the shape of this arr dot shape? What is the shape of arr? That is 2 cross 5. That is 2 rows and 5 columns. If you see there, you have this one row and this one row. So 2 rows and 5 respective columns. So this is one column, this is second column, third column, fourth column, fifth column. You can even see it like you are having two rows, and each of two rows you are having five elements. Okay. Similarly, so this is like a one dimension or a two dimension. Now if I say that there is something as zero dimension, so what is a zero dimension? If I say an array, so this is an array, but what is the dimension of this? That is, alright, 1 minute, sorry. This is an array, right? If you see the type of this, this is an array. But what is the dimension? We need the dimension. That is 0. So this is a zero dimension figure, or else you can say that array without a bracket is having a zero dimension. Got it? So it starts from zero dimension, one dimension, two dimension, three dimension, multi dimensions there, right? So that is why it is stated to be as n dimension figures, right? Now if you want, if you have stated that ARR as np dot an array, and you have said it to be 1, 2, 3, 4, 5. Now we know that this is a one dimension figure, right? So you know this is a one dimension figure, a one dimension array. But I want this as a two dimension. So in that case, I will have to define that the number of dimensions should be minimum 5, 2, right? So minimum number of dimensions we want is 2. At least there must be two dimensions. Then that is like ARR, we want to print it, and we can see it to be two dimensions. Even if we have written it in one dimension, we are getting it in two dimensions. So endim is 1 minute. Endim, and there is a difference between this endim and endimin. Many times students get confused. So these two things are different. Endim is used to find the number of dimensions, and endimin is used to state the number of dimensions, minimum number of dimensions you want, according to that. Okay. Now, let's say if we just go to access the elements, if we say that this is an array and this is 0, 1, 2, 3, right? So what is the ARR of 2? That is 2 exactly, 0, 1 and 2, right? What is the ARR of -3? That is 1. It is -1, -2, -3. I like that, indexings and all, right? So you can go to a bit of good indexing like let's say this time I'm taking it to be two dimension. Now if you say ARR of 0, so in this case you'll be getting the whole first element, that is 1, 2, 3, right? Because this is completely defined in one particular you can say array, and there you have this as 0 and this is 1. So if you say 0 of 0 of 0 plus ARR of 0 of 1, so that is 3. Why? Because this is 1 and this is 2. So 2 plus 1 is 3. If you change up the things, 1 of 1, that is for 5, and that is of 1. So 5 plus 1 is 6, right? And similarly, just print up. Like if we just print a comma, you can see 1 comma 5, and we are just going to add it up, and then it goes with this, right? 6. So basic addition, subtraction, and all with the indexings of the arrays, you can do it there, right? Okay. Now we see a bit of complex arrays. All right. So let it be 4, 5, 6. Okay, so this is 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now, what is the shape of this array? One array, there's 3 rows and 3 elements. Nice. Now, what is the size of this array? Okay, we'll go on size later onwards. Let's just see first what is the dimension of this array. 3 dimensions. Nice. Print this array. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the ARR of 0? The whole thing you are getting now, right? If you write ARR of 0, you'll get everything because this whole is defined in one particular thing, right? So ARR of 0 or ARR of 0 of 0, in that case you'll be getting the first one. Okay, this is how it goes on. So let's say if I am saying, let it be there. If I am saying ARR of 0 of 2, so in that case we are getting 7, 8 and 9, right? That is 0 and 0 of 2. Alright, so even if you don't write like this, you can write it like this, right? So 0 of 2 is, so this is a complete 0 and 2 is 7 and 9. If I say 0 of 2 of 1, so there you are getting 8, right? So don't be confused with that, those respectives. So this is the whole 0, right? And this whole 0, 2 is 7, 8, 9, and the 0 of 2 of 1, that is of this 2, the 1 is 8, right? So that is all about the indexing things. So anytime in anyone, right, if you get it like this, then you should be recognizing the things, how these things are coming up. Okay. Similarly, you can even go with the respectives of -1 to -1 to -1. Minus, that is 9. So -1 of -1. What is -1? That is -1. This is -1, right? So -1 of -1. This is whole -1, and then the -1 is 7 and 9, and the -1 of this is 9. So with respectively, you are getting up the answers, right? Should be very clear regarding the things when you are solving up the problems of an array. Because when you deal with the models, machine learning models, when you go with the computer visions and all, there you come to see with some numpy arrays, and that is important to handle up those things there. Alright. So that is how we just slice up the things. Let's say if I'm saying that this is an array. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Alright. So this is an array. Now, when I'm saying that array of 1 to 4, array of 1 to 4, that is through 3 and 4, right? It's from 1, you'll be getting right 1, 2 and 3. Because in range, if you remember right how the range works, because I think you all know about the bit of Python, so ranges and all would not be a tough task for you. 4 to 6, 5 and 6, right? Just giving you a glance of things, reversing the rest. Sorry, the array. -1 to 2. So 9, right? So from -1 in the intervals of 2, you are trying to get at those things. So from the -1, you are trying to print in the intervals of 2. So you'll be getting up to 9 over there, right? If you apply anything there, it will be changed, empty. So let's say for 2, even if it is -1, alright, -4. Cool. So we are getting some empty things. Let's say for this, now we'll be getting up something, right? So negative indexing can be done, positive indexing can be done, steppings can be given, like the intervals can be given. We can even slice up the 2D arrays, right? If we say that like np dot array, and This is 1, 2, 3, 4, 5, and this is 6, 7, 8, 9, and 10, right? If I'm saying that I'm gonna slice it with 1 and then 1 to 4, you're getting 7, 8, and 9. Why? Because ARR of 1, what is ARR of 1 if you see other things? That is 6, 7, 8, 9, and 10. And among that, what is the ARR of 1 and then 1 to 4? So ARR of 1 is this, right? And starting from this 1, what is this 1 to 4? Right? If you see up this ARR of 1. So this is right? So what is this 1 to 4 means? 1 to 4 means the numbers between 1, 2, 3, that's it, right? So it is particularly stating you that this is starting from 1 and it is going till 1, 2, 3, right? So till 1, 2 and 3. So what is 1, 2 and 3? That is 7, 8 and 9. Exactly, right? So you're getting other things, 7, 8 and 9 and so on. That is being like printed up, right? Okay, next. So in that sense, you can go for even indexings. Now let's say like in the list we had ranges and all to print up the numbers for even thousand of letters, right? So in this case, what we can do is here we can write let's say this is X and this is an let's say this is an array which is going to be an range. So a range is nothing but an array's range, right? So let's say for 100 and print ARR. So you can see 100 numbers over there, right? So you can see from 0, starting from 0 till the 99. Similarly, if I say that if you want the first 10 numbers, 20 numbers, 50 numbers, you can just define of the things and sorry, one second, and you can get it for respectively, right? You got it? What is the difference between the things? Like if I say X is equals to 30, or X is equals to a blank list, and if I say for I in range of 100, 101, that's 100, X dot append I, done. So what is the difference between this X, between this list and the numpy? Both are doing the same task. You're getting up the things over here too, and you're getting up the things over here also. And let's say printing ARR and printing up this list. So can you see up the things over there? Any difference? The common difference is the very minute difference you can say is that if we see up the printing in the list, every numbers are in the order, right? Every one number is coming one after exactly one after one, right? But in this case 1, 2. So here the comma has been like shuttered off in the, like it is, let's get for first here. Here you can see some things over there, right? 109 after the things. Here you can see 7 coming up there, right? So there is some unlinearity of this commas between from 0 to 8, that's single digit numbers. Then it is linearity, right? There it is fine. But here we can see something over again like that, right? But in the case of arrays, you can see everything in a very linear way, even if it is a single node. So everything is very linearly arranged over there, right? Okay, so that is a very minor difference between a list and arrays, that things are very arranged in this array, and in the list it is fine doing some work but not very good as compared to the arrays. Okay. So also list is lagging behind in the spaces, or not in spaces, I mean to say about the size what it takes, right? In that sense. All right. Now, what is the type of an element you? What is the type of the? What are the data types of the element you have stored in the list? That are integer, right? So, what is the major difference? That is in the list you can store various data types at a time, but in an array you can store only one data type at a time. At a time, right? Let's say if I say even only one number over there, if I make an array, let's see, and I say here 1, 2, 3, 4, 5, and I write it as 5.0. So everything will be converted into a float, right? So you can only have one typical type or data type in array, right? So it follows the homogeneous okay, so homogeneous it is followed by that, right? It is not, it's not following the list like an heterogeneous collection of data with respect to the elements, right? So it only follows this homogeneous. So we say D type to be the complex, everything would be in complex, right? So that is like how if you define of the things, right? So if we allow, let's say that I have introduced this D type, so let's just see it what it is. So D type actually tells you about the data type your array is about, right? So it is integer 64. You can even find the D type dot name to find out like what is there. So it is integer 64. All right. So similarly, what are the lengths? In the list we used to find the length, right? So length of an x, that is 100. Length of the ARR, that is 100, right? So what is the alternative method to find out the length in the NumPy arrays? So you can go with finding out this as np dot. Okay, leave that. Just write this and then go for the size. That is an alternative method you can say for finding out the size of your array, or the total number of elements present inside your array. Okay, and even if you want to find the individual element size, right, if we just say that import sys, and uh, let's say sys dot, all right, so what is the total size of x, what is the stake, so x dot underscore underscore size of, once again there is some mistakes I think. Where does that, it's gone, some minute errors has been done I think. Get size of runs. So, like your X is a list which is storing some 888 bytes. Hmm? But what is the size of this array? So 896. Okay. So respectively 896 the bytes and the total things in there. Alright. So what if we just say it to be like, if we compare up the things regarding the individual element size. So if we say that sys dot get size of this x, so 920, right? So sys dot get size of ARR 896, right? So this is, I think it's something getting wrong over there. 888 is something wrong there. All right. Why it is coming wrong? Don't worry. Might be some issues with respective. All right. Okay, so we are getting the total size of this X to be 920 and the total size of this array to be 896. You can see the difference that NumPy arrays are always less as compared to this, right? Okay, even in the tuples, even in the dictionaries, even in the case of sets, or like if we say even for this, what to say, even for this, uh, the cases of you can say the pandas and all, right? We'll see of those things, right? So the size of this arrays matter, right? So arrays are very fast as compared to this less numpy arrays. In the case of the size, in the case of the time execution, you can say on, right? So in that cases, these are much better. So what are the item size? So if I say the item size, that means that individual element size. So what is the individual element size of any integer? So I think you might be knowing it, right? It is always 28 bytes of an integer. But what in case in NumPy arrays it differs, right? According to the data types it is being taken off, right? So there it is like the item size. So there it says about the you are having exactly the size of the element, that is 8. Now how this item size is coming, right? How this item size is coming? What is the data type of your array? If you see the data type of this array, that is 64. So whatever the size it is, right, you have to divide it by 8. So let's say the last thing is 64. So 64 divided by 8 and you are getting it 8, right? So that is exactly your data type. Now let's say that if you are making an array, if you are making an array and you are defining it to be 1, 2, 3, 4, 5, and you are saying that np dot, sorry, your data type would be np dot integer of 16. Now, if you say it like this, if you just define up the things, all right. If you say it like this, right? If you define that your data type should be of 16 bytes, right? So you can see your data type is integer of 16, right? So if you see arr dot n, sorry, you see arr dot this d type dot name. So that is integer of 16. Okay. Now what I say that to find the item size, always the last is to be divided by the 8. So this is 16, 16 divide by 8, and so we are getting 2. So if you see the data type, sorry, item size, so we're getting it as 2. Okay, that is how it is being find out, right? Okay, cool. Alright, moving up. So this is how we can find the item size, the shapes and all, right? Now let's say if you have an array, np dot an array, and let's say it is a kind of a 2 cross 3 array, that is, I mean to say 2 rows and 3 columns. So 2 rows and 3 columns over there. If you see the ARR, alright, let's say this is an A. So ARR dot the shape, that is 2 rows and 3 columns, or even we can say it's to be 2 by 3, right? So in this perspective, basically, if I say you that I want to change this, I want to reshape this, so I'll be reshaping it to let's say 3 cross 2. So I'll be getting an array with the 3 rows and 2 columns with the change in some respectives of there, right? All right. But there comes the questions, right? If you reshape any array with respect to -1, in that case, every array, even if it is a 10 dimension array or 100 dimension array, it will come down to this one dimension, right? So negative of any value, right? Not even for only -1, negative of any value will be giving you the arrays in the one dimension. Similarly, it is same for this Ravel and all. So this ARR of Ravel will be also giving you the same thing, right? What reshape of -1 is giving you. So that is making the arrays in one dimension. If you want your full array to become in the one dimension, you can make it with that respective. Okay. Now moving up. All right. Now let's say that you want to find. Now as I said that it is important in the case of the mathematics, then how it is important there, right? So let's say you have a number. You are having two. You're having four. You're having 16 and such like that. Some numbers over there, and this is an x, and this is np dot. Array of this. So what is x? 4 and 16. But when I say that np dot sqrt of 4, this x, so this is 2 and 4 itself, right? And if you want that your outcome should be always in an integer format, right? So you can apply that which kind of things, no loop matching with the specified signature and type as functions and functions is square root. Okay, fine. No issues. So like this you are getting up your 2 and 4 like for the square roots. Okay. What more you can do is you can find the log value of this x. You can find the log value with the base 10 with this x. Now let's say you want to find the np dot log 10 of this 10. So that is 1.0 if you guys remember of the thing, right? Even if you find the sign of this x, so this is the sign values, right? The cos values and the tan values and all. So what is np dot tan divided by the np dot sine, right? Okay, just like this, write some angles over there. So x and np dot sine of x. So some calculations can be given up there, right? np dot infinite. So this is an infinite value, right? In the SIMPy we say it as, if you remember of the things. So in SIMPy we say infinite as this, right? And in NumPy we say it to be an infinite value. If it is a NaN in SIMPy, we just simply write it as s dot nan. If you remember these things, but in case of a NumPy, we write it as nan. That's it, a NaN value, right? So things changes as perspective to each modules, each libraries. Okay. Now let's say you have two numbers 2 and 4, 2 and 4, and you want to find 100 numbers between 2 and 4. What can you do? You can apply some linearities there to find like 2, 2.1, 2.2, 2.3, and then you can go for the 100 numbers. But what is the linearity, right? When I say the linearity, that is, I say that you find 100 numbers between 2 and 4 and there should be equal gaps, right? So you can apply the arithmetic progression and you can just find out that the a plus n minus 1 into d, and then you can find the common difference to be there, and then you can go with that, right? So for going with all that long procedures, what we can do is, yeah, you can apply the things, right? If you just remember of the things that a equals to n minus 1 multiplied by this d. The formula a equals to n minus 1 multiplied by the d, right? That is, let's just say, so a equals to n minus 1 multiplied by d. So this is the symbols a and d. You see your a, that is d multiplied by n minus 1, right? Now you can, if you define that, you know that what is a. So a is equals, your a is equals to 1, right? Sorry, 2. and you know it to be the n minus 1, so n is your 4, I say, right? And there you have said that it is to be 3, right? So a is equals to n minus 1 into d. Sorry, a plus 1, what is this here? Something I'm missing, I think. Yeah, so this t equals to a plus n minus 1 into d. So this is like this. So a plus n minus 1 into d. So you can apply, right? A is, if a or a is equals to 2, and if you say your d is so d you need to find up, and you say your n is equals to 3, right? So you can quickly find up the things, and you want some 100 numbers from the respective of the t, right? So you can calculate up the things, right? If you say your t, it would be a plus n minus 1 into d. Now a is 2 and n is 3. So you can replace up the things right here, and you can find it there. What should be the minimum thing, right? So if we calculate on from this perspective, so we say it to be 2 plus your d into n minus 1, right? So 2 plus d into n minus 1, so it would be d, and then it would be n minus 1, that is multiplied up by 3, right? So 2 plus 3d, that is 2 plus 3d perspective, right? Let us see it to be an expression. So this is 2 plus 3d, and this is exactly 100 minus 2 equals to your 3d, if you just see of the things, right? So this is an expression basically, right? That is 98 is equals to 3d. 9d, or let's say 3d is equals to 98. So 3d equals to 98. Kind of sign the things. This is an expression, let's say. So here this 3d is equals to 98. That is d is equals to 98 divided by 3. And you are getting d as your 32.666 and so far, right? So you got some common difference for the 100 numbers. So what you will do is, like, you will be adding up this 2 plus 32 point all this value what you have. So 2 plus d respectively, right? So 2 plus d, that is this. So you will be doing it as, let's say, x is equals to a list, and then for I in range of 100, 2 plus d I sorry 2 plus d, right? You can write it as 2 plus d, but that will not make a sense over there exactly. If I run this event, you can see your x. So you're getting up the same things there, right? So you also have to increment up the things. So just for not going on all these, if we just have a simple thing out there to do our task, that is a linear spacings, right? So that is just like a one line code. So you want the numbers from 2 to 4, right? And you want some, how many numbers? 100 numbers. So these are your 100 numbers with the equal spacings. Okay, so these are the 100 numbers with the equal spacings. Now, how we can say that these are in the equal spacings? So let's say we want to return the steppings it is taking up there. So returns the steppings true. So getting a stepping that it is taking 0.02, 0.02020, and this is the stepping it is taking. So for taking up the numbers from the 0 to 2, it is taking up these things, these stepping. So we got the stepping as 32 points something, right? And it's taking some steppings to be there for 100 of the numbers. That is not the equal steppings we are there. That is the total number of terms we are having, and then we are subtracting the things to find the common difference. Alright. So like you can use the length space. Similarly, you can even find the log space. From 2 to 4 of some 100 uh, in that sense. So from 2 to 4, if you want to find the log space, you can get it with that respectively. Okay, so there are a lot of things in the calculation part itself to complete up with those things. All right. What more you can do? You, if you want to find the LCM, right? Let's say you have X. If you remember your ARR, that is particularly this, right? So if you want to find the LCM of this, so how you can find the LCM in this number, right? If you find the LCM of 2 with the 4, that is exactly 4. But what in the case of an array? So if you want to find the LCM of an array, first you have to reduce it. That is LCM dot reduce, and then you have to write the array name, and then you can get it there. So LCM of 1, 2, 3, 3, 4, 5 is 3, 4, and 15. That is LCM of 1 and 3 is 3, LCM of 2 and 4 is 4, and LCM of 3 of 5 is 15. Like that, right? Let's say if you want to find the greatest common division, right, that too also of an array, so you always have to reduce it, and then you can find the things. That is 1, 2, and 1. So 1, 3, 1 and 3 HCF is 1, 2 and 4 HCF is 2, and 3 and 5 HCF is again 1. Okay, that is being perspective of that, right? All right. Now let's say if I say from random. So importing random, let's say if I say np dot random dot rand. So you're getting any random number between there, right? Any random number there. So if I say random of 10, so I'll be getting some 10 random numbers directly. And when I say that I want to reshape this in some 5 cross 2, so I can get some 5 rows and 2 columns of that random numbers. Every time it will be a new number over there, right? Okay, got it. So you can write it according to that. Now, if I say that I want a random number of my choice, right? A random number to be printed up, but of my choice. So I want the numbers 2 and 4 to be printed, and the probability I am giving it there, let's for 4, 0.4 and zero point 0.6, and the size also I am giving it to be 2 cross 5, and I want the elements in the 5 cross 2, size 5 cross 2. So you can see of the things that I have gotten array, but of my choice, right? That is, the numbers are of my choice. That I want only 2 and 4 to be printed, and only 2 and 4 is being printed for 5 times. Or you can say for the 10 times in the occurrence of 5 to 2. That is, your 2 is being printed for 40% and 4 for 60%. So you can see the number of 4 much as compared to the number of 2. So if you want to find, like if this is your y is equals to this, and you are printing up your y. So this is your y, let's say. You are printing this y. So let's say we just want to find that where this 4 is there, right? So where in the y there is 4. So it says that this is in the array of 0, 2 and 3, and then array of 0, 0 and 1. So if I say the y of 0, 2 and 3, so okay, so y of 0 this is, right? So y of 0 is 2 and 4. So you're getting up the 4 there too, right? So we'd have to write the y of 0 of 1, then the y of 0 of, the y of 2 of 0, and then the y of 3 of 1, right? So what you're getting is like the 0 of 1, the 2 of 0, and in that respectively with print, and we are getting 4 over there. So we are having 1, 2 and 3 fours, and we have given this 2 as to be 0.4. So we're getting 1, 2, 3, 4, 5, 6, 7. Got it, right? So if we say that we want these things to be up for size equals 50. Now in this case, your y is going to be changed. That is, you can see up the fours here much better than from previous one. So from where this y, so here we'll be just searching for the 2. So these are the positions where we are having 2, right? So we can find y of the respective things you are getting there, right? That is these much. Let's just say copy. Let's say this is S, your elements up there, and let's say that for the u in S, print y of u. So you are getting all the numbers as 2. Why? Because these all numbers are there in the or these all index positions are holding the number 2. So you're getting every time 2 over there, right? So apart from this, if we just say that where np dot where in this y is not equals to 2. So these will be the places where the y is not equals to 2. So we just copy this and we say it to be g equals to something like this. Sorry. G equals to this, and if we say for g in for I in G, print y of I. So here you'll be getting up all the fours if you see of the things, right? Okay, got it. So like this you can go up for the calculating on the numpy arrays, and you can find up more things with there, right? So for copying an array you can basically use np.copy and you can copy up the things over there. Okay. To that perspective, you can do a lot of more things in the case of NumPy, right? So you can perform a lot of operations. You have seen like how to perform with the random things, how to perform with the size, how to go up with the uh, basic calculations. So you can like if you have an array in np.an array, right? So this is an x and this is a y, which is copy of x. So x comma y would be 1 2 3 4 1 2 3 4. So you can add up x and y, right? You can subtract this x and y. You can even concatenate on the basis of the stackings. So you can concatenate this x and y, right? You can even concatenate in the vertical stackings. So vertical stacking will give you the vertical concatenation particularly. So let's say you're concatenating it with the vertical stacking, and that is this, right? So when say it to be horizontal stacking, it will be changed, right? So in particular row, everything will be there. So that are the things. If I write it as d stack, so in the respective depths and all will be taken up the things 1 2 3 4 1 2 3 4, right? So these are common operations we perform on the NumPy, right? Okay. So that is very important to deal up, right? So tomorrow we'll be starting up with the data extractions. Okay. All right.